Welcome, eco-warriors and tech enthusiasts. Today we're diving into the crystal-clear waters of predictive modeling. And no, we're not talking about forecasting the next fashion trend or predicting the winner of the World Cup.
Although, Mark, I wouldn't mind a model that could predict when you'll finally return that book you borrowed. It's been, what, 2 ice ages now?
Very funny, Tom. But speaking of ice ages, we're actually here to talk about something much cooler. How AI is helping us predict environmental trends. It's like having a high-tech crystal ball for our planet's future. So Tom, imagine if instead of just telling you whether to bring an umbrella tomorrow, your weather app could predict climate patterns for the next decade. That's essentially what we're dealing with here, but on a much grander scale.
Absolutely, Mark. It's like upgrading from a magic 8-ball to a supercomputer. These predictive models are crunching massive amounts of data to forecast everything from climate change impacts to biodiversity loss.
Exactly. And you know what's really mind-blowing? These models can simulate complex scenarios. It's like playing SimCity, but for the entire planet. I once worked on a project where we used these models to predict the long-term effects of different policies on coral reef ecosystems.
That sounds fascinating, Mark. Can you give our listeners an idea of what kind of data goes into these models?
Sure thing. We're talking about a smorgasbord of data: ocean temperatures, pH levels, fish populations, even human activities like fishing and tourism. It's like trying to solve a 1,000-piece jigsaw puzzle, but the pieces keep changing shape. Now let's talk about the secret sauce that makes these predictive models so powerful: machine learning algorithms.
Ah, yes, the digital Sherlock Holmes of our time. These algorithms can spot patterns that even the keenest human eye might miss. It's like having a tireless detective sifting through mountains of environmental clues 24/7.
Exactly, Tom. And the best part? These algorithms keep getting smarter. In a recent urban air quality project, we used deep learning techniques to analyze data from a network of IoT sensors.
Let me guess. It was a breathtaking success?
Oh, Tom, your puns are as predictable as, well, our models. But yes, the results were impressive. We could predict pollution hotspots with remarkable accuracy, helping city planners implement targeted strategies. It's like giving cities a pollution GPS. Now, before we get too carried away with our AI crystal ball, we need to address the elephant in the room, or should I say, the uncertainty in the model.
Ah, yes, the classic garbage in, garbage out dilemma. No matter how sophisticated our models are, they're only as good as the data we feed them, right?
Spot on, Tom. It's like trying to bake a cake with questionable ingredients. You might end up with something that looks like a cake but tastes like a science experiment gone wrong.
I see what you did there, Mark. So what are some of the main challenges we face with these predictive models?
Great question. We're dealing with incredibly complex systems here. Natural environments are unpredictable, and then you throw human behavior into the mix. It's like trying to forecast the weather on a planet where everyone has a personal weather machine. We need to constantly refine our models, incorporate new data, and most importantly, validate our predictions against real-world observations. Now, Tom, let's put on our Wardley mapping hats and take a look at how predictive modeling fits into the bigger picture of environmental sustainability.
Ah, I love a good Wardley map. It's like a GPS for strategy. What insights can we glean from mapping out predictive modeling?
Well, if we look at the Wardley map for predictive modeling of environmental trends, we see some interesting patterns. At the top of the value chain, we have environmental management and policy interventions. These are the visible outcomes that directly impact our planet.
And I'm guessing predictive models themselves are somewhere in the middle, right?
Exactly, they're in the custom-built stage, moving towards product-like. But what's really interesting is what's happening at the bottom of the map. We see things like advanced machine learning algorithms and quantum computing research in the genesis and custom-built stages.
So these emerging technologies could really shake things up in the future?
Absolutely. The map suggests that to stay ahead of the curve, organizations should focus on developing these cutting-edge technologies. It's like investing in a crystal ball upgrade.
Fascinating stuff, Mark. It really highlights how predictive modeling is at this crucial intersection of evolving technology and urgent environmental needs.
Couldn't have said it better myself, Tom. The Wardley map really drives home the point that while predictive modeling is becoming more established, there's still a lot of room for innovation and improvement in the underlying technologies. Well, folks, we've journeyed through the fascinating world of AI-powered environmental crystal balls. From coral reefs to city smog, these predictive models are giving us a sneak peek into possible futures of our planet.
Indeed, Mark, it seems the future of environmental science is as much about bits and bytes as it is about flora and fauna. But let's not forget, even the smartest AI can't replace good old-fashioned human judgment and action.
Absolutely right, Tom. So, dear listeners, next time you hear about climate predictions or environmental forecasts, remember, there's a good chance AI played a role in painting that picture of the future. Until next time, keep your carbon footprint small and your environmental awareness large.